All right, gang, so topic 3 review. This is question number 1, and this is asking to decide which of these polynomials would be a polynomial that would have this, oops, sorry, let me change the color. You can see this shape over here. So already I know it's an odd function because the ends are going in opposite directions. So that tells me that this isn't an option and this isn't an option. Then I have to decide whether or not it has a positive or a negative leading coefficient. So remember, x cubed goes like this, and x to the negative x third goes like this. So this one looks like a positive x to the third or fifth or seventh or an odd power of some sort. This would be a negative x to the odd power. So I am going to pick this, just kidding, going to pick this option right here where it is a positive 8x to the fifth. So I'm only looking at the leading term. The other option is that you can Desmos graph all or the one that you think is the right answer and see if it looks like this guy. All right, this one I have 3 parts. I'm looking for a cubic function, and that's the big thing to remember. These are all cubic, which means that they're all going to go, they're going to have this shape or this shape. They're going to have different endpoints. One will point up and one will point down. If they both point the same direction, they can't be cubic. So like I can eliminate this from each one of them. Then I'm looking for how many intercepts does it have. It has 1 x-intercept. So how many times does it cross the x-axis? So which one of these? Now this one crosses twice. B crosses 3 times. A is the one that crosses once. On the next one, I'm looking for 2 x-intercepts. So A crosses 1, 2, 3 times. B crosses 1 time. This one crosses 1, 2 times. So D. And then our last guy, we're looking for one that crosses 3 times. So 1, 2, 3, that's this guy right here. All right, this one I need to do all 3 parts. I didn't copy down all 3 parts from the picture. I'm just going to do part 2 and part 3 kind of independently. So the polynomial in standard form means that I start with the largest exponent, so 3w to the 4th. Then I go to the next largest, so that's our squared term, minus 2w squared. Then our single, 4w, and then our positive 18. That would be standard form. My degree is the largest exponent, so my degree is 4. And my leading coefficient is the number in front of that largest exponent, so that's 3. Okay, this one, I'm going to use the leading coefficient, or I'm going to graph it on Desmos. That's why you've got this graph right here. I went ahead and graphed it on Desmos. So as x goes to positive infinity, that's this direction, where does y go? Well, y is going to negative infinity. So this is going to be negative infinity. So you don't have to necessarily do anything other than graph it. If you want to actually use the leading coefficient test, I would rewrite this as negative 8x to the 6th plus x. The leading term is negative 8x to the 6th. Because the exponent is even, that means it's going to either go this way or it's going to go this way. Because the coefficient is negative, it's going to go this way, which means, again, as x tends to positive infinity, I'm going down, so y is going to go to negative infinity. Here, I'm just going to add the like terms. That plus there means that I really don't even need these parentheses. I just need to find who looks the same. And I'm going to start in descending order. So this is going to be the first thing. Now, negative x squared doesn't have any friends, so he's just going to write negative x squared. If you like, you can mark them off as you go. Our next one is going to be an x term. So it looks like 2x and negative 2x. Now, if I have $2 and I spend $2, I have $0, so I don't need to write anything down there. And then our last one is 8 plus negative 11, so that would be 8 plus negative 11 is negative 3. And that's what I would put in right there. This one's a little bit trickier because it has that minus sign. Now, I have seen people distribute the negative and turn everything positive. That may be the best strategy for you. If you don't like that, you can do the same thing we did on the last screen, but then instead of adding things together, you're going to subtract them. So I think most students have better luck with distributing the negative. This is like a negative 1 here. So this is 3y squared plus 5y minus 9. Negative 1 times negative 2y makes positive 2y. Negative 1 times positive 8 makes negative 8. Now I'm going to do that same strategy as before, and I'm going to put the things together that are alike. 3y squared, no friends, so he just stays as 3y squared. Then I'm going to go and do 5y goes with his friend 2y. They're both positive, so I'm going to do 5 plus 2. That's, oh, let me change my color to the right one, blue there. So plus 7y. And then our last guy, negative 9 and negative 8. So if I have negative $9 and then I go negative $8 more in the hole, I am now negative $17. So that would be my final answer. Okay, this is distributive property. So 6ab times xa squared is going to be 6a to the third. So a times a squared is a to the third. B tags along, no friends, and then plus x. And then I'm going to go next this way. So I'm going to go plus 6. A times a to the 9th is a to the 10th. B tags along. Y has no friends. And our last guy, we go this way. So 6 times negative 5 is negative 30. Then just a B. That'd be it. Okay, this is the best example of why Ms. Zender doesn't like FOIL. So if you ever were taught first, outer, inner, last, it will not work on this kind of problem. So instead, I like to double distribute. I'm going to distribute x to everybody in here. And then I'm going to distribute negative 6 to everybody in here. So I'm doubly distributing. I'm distributing this, and then I'm distributing this. So if I go step by step through that process, I go x times x squared is x to the third power. X times negative 2x is negative 2x to the second power. X times 4 is going to be plus 4x. Negative 6 times x squared is going to be negative 6x squared. Negative 6 times negative 2x is going to be a plus 12x. And let's get one more color. We'll go orange. And negative 6 times 4 is going to be a negative 24. Now I got to put things together that are alike. So if I look at my first guy, it looks like x cubed has no friends, so he's just a plain old x cubed. Mark him off. Now I'm going to go negative 2x and negative 6x. So negative 2 minus 6 is negative 8x squared. Mark them off. 4x and 12x is positive 16x. Mark them off. Last is negative 24. This one's a lot longer, but it's the same process. It is really important that you notice that it does not matter how I put these in order. Order doesn't matter. So there are 3 binomials. I can do binomial 1 and binomial 2 together first, or I can do binomial 2 and binomial 3 together first. Or I could do binomial 1 and binomial 3 together. It makes no difference who I multiply or in what order I multiply them, just so long as I keep track of who's getting multiplied. So my first one that I'm going to do is going to be just the first 2, this and this. So I'm going to go 3x times 3x. That's going to give me a 9x to the second power. Then I'm going to go 3x times negative 5. That's going to be a negative 15x. Then I'm going to go with my 5. 5 times 3x is going to be a positive 15x. And then I'm going to go with 5 and negative 5, and that's negative 25. Now, this is these two multiplied, so I still need my 5y plus 6x. But in order to make this a little simpler, I'm going to rearrange what's happening over here, and I'm going to combine like terms. Negative 15x and positive 15x actually cancel each other out, so I end up with 9x squared minus 25 times 5y plus 6x. Now I'm just going to double distribute. So let's grab my colors again. So 9x squared times 5y is going to be 45x squared y. 9x squared times 6x is going to be 50. Actually, let's try that again. Let me go in my other color. 9x times 6 is going to be 54x cubed, because I have an x squared and an x makes x cubed. And I'm going to do this guy. So this is a negative 25. His sign comes with him. Negative 25 times 5. So if I had 5 quarters, I would have 125 cents. So, or you can do that in your calculator. And then I have 25. Oh, sorry. Let me get my color. Sorry, technical difficulty. Negative 25 times 6. So if I had 6 quarters, I'd have $1.50. So negative 150x. There are no like terms, so the final answer is just this guy. Okay, so remember this is sum and difference of cubes. This one I'm going to use the difference of cubes because it has a minus. And so that's going to be same sign as what you're doing, opposite sign, always positive. Okay? So here I have to figure out what is cubed. So x to the 15th is what thing cubed? Well, x to the 15th is the same thing as x to the 5th cubed. 5 times 3 is 15. And then if I do the next one, y to the 9th is the same thing as y to the 3rd cubed. So that's y to the 9th. 3 times 3 is 9. So my problem, x to the 15th and y to the 9th, becomes x to the 5th cubed minus y to the 3rd cubed. What that tells me is that this is my a and this is my b. So when I'm plugging it in, a minus b, it's going to be x, let's go the right color, x to the 5th minus y to the 3rd. That's my a and my b. Okay. Now, that's my a minus b right here. Then it's a squared. So a squared is x to the 5th squared plus a times b. So x to the 5th times y to the 3rd. Always positive, plus, and then b to the 3rd is y to the 3rd squared. So now if I simplify, it's going to be x to the 5th minus y to the 3rd. X to the 5th to the 2nd power is x to the 10th plus x to the 5th, y to the 3rd. Y to the 3rd to the 2nd power is y to the 6th. Okay, so this is the same. And we're going to do the difference of cubes one more time. So again, we have to figure out what the cube is. So what is A and what is B? The first one is 8, and I know that the cube root of 8 is 2, which means 2 to the 3rd power is 8. So I could rewrite this as 2 to the 3rd minus m to the 3rd. So what that tells me is that A is 2 and B is m. So I'm going to write A, which is 2, same sign, minus B, which is m, times A squared, so 2 squared, opposite sign, so plus, then A times B, 2 times m, then always positive, and That's b. So that's m squared. The only thing I can simplify here is that right there, that 2 squared. So this is 2 minus m times 4 plus 2m plus m squared. Okay, so now we have to do some long division, or you can use synthetic division on here if you wanted to. You don't necessarily have to use long division, and the reason I can use synthetic is because there is no coefficient of x. So I'm going to show you both ways. If I do long division, then I'm doing x minus 8, and I'm dividing it into x cubed plus 0x squared plus 0x minus 512. So I know that I need to do x times something to give me x cubed. So that times something is going to be an x squared. When I multiply that out, x times x squared is going to give me x cubed. X times negative 8 is going to give me negative 8x squared. So now I'm subtracting everything. So this is all minus this bit. So that's going to be x cubed minus x cubed is going to give me 0. So those are going to cancel. And 0x squared minus a negative x squared is going to give me 8x squared. So it's a positive 8x squared, and then bring everybody else down. Okay, so now I have to fill in again, but this time I want to match 8x squared. So if I make a positive 8x, then when I distribute, 8x times x is going to give me 8x squared. 8x times negative 8 is negative 64x, and then I'm going to subtract. Now, 8x squared minus 8x squared, because remember this is all subtract, that's going to cancel out. 0 minus negative 64 is going to give me a positive 64x minus 512. Now, last but not least, I'm going to try and match this 64x, so that's going to be a plus 64. So I'm going to get 64x, and I'll grab my calculator. And that actually gives me, guess what, minus 512. Everything matches exactly, so everything cancels out, and I get a big fat remainder of 0. And so the quotient is x squared plus 8x plus 64. So let's see what this would look like if I would have used synthetic division instead. So I would take the denominator, x minus 8, and I would change the sign of the negative 8 to a positive 8. So I'm going to write that as an 8. Then I'm going to do an upside down division bar, and I'm going to fill in with just the coefficients. So 1 is the coefficient of x cubed, 0 is the coefficient of x squared, 0 is the coefficient of x, and negative 512. Then I bring the first guy down, and I call that a 1. Now I'm going to do 8 times 1, which is 8. Then I'm going to add these together. 8. 8 times 8 is 64. Then I'm going to add these together. Then 8 times 64 is 512. Add those together. My remainder is 0. Now, when I pull my answer, I take, this is my last term, so it's the term with no variable. Then it's a positive 64. Then this is the next term. So the x to the first power, and then the last one is x to the second power. And if there were more, I would keep adding on. So I get the same answer, but it takes me way less time and way less work. So let's do this one by synthetic division. So I'm going to call this 3. And then my coefficients of x to the fourth is 5. My coefficient of x cubed is negative 19. My coefficient of x squared is 13. My coefficient of x is negative 5. And then 6 is my guy. Bring this one down, and I get a 5. So 3 times 5 is 15. Negative 19 plus 15 is 4. 3 times 4 is 12. 13 plus 12 is negative 4. Sorry, so that's negative 12, so that gives me a 1. 3 times 1 is 3. Negative 5 plus 3 is positive 2. And 3 times 2 is 6. And that gives me, did I do it right? -2, -6, 0. So you can kind of see my thought process of why, when I was working, how I got to like, say this guy. And I was like, wait a minute, that's going to give me a really big number if this is not negative. It's going to give me 25. And 3 times 25 is going to give me 75. And then there's no way I'm going to get a remainder of 0. And most of these are going to be remainders of 0 for you guys. So I was troubleshooting thinking, what did I do wrong? -19 plus 15 is actually a -4. Okay, that makes this a -12, so I get a +1. And then over here, when I got to 2, I was like, well, if this is a +6, then they don't cancel out. So I double checked, -5 plus 3 is -2. Now, how do I pull my answer? The -2 has no variable. Then the x has one variable, it's just 1x. Then it's going to be x squared, and that's going to be a -4 in front of it. And then it's going to be x cubed, and that's going to be a 5 in front of it. All right, so same thing. Let's try it again. Synthetic division, and we're going to go the opposite. So +2 becomes -2, and then it's x cubed. The coefficient is 1. X squared's coefficient is 10. X is coefficient is 13, and my constant. So the 1 comes down. I do -2 times 1 is -2. When I add these together, I get 8. -2 times 8 is -16. When I add these together, I get -3. -2 times -3 is +6, so I end up with a remainder of 20. I'm double checking my work here because I'm thinking maybe I shouldn't have gotten a remainder. So I'm going to go again, -2 times 1, that's -2. 10 minus 2, or 10 plus -2 is a +8. -2 times 8 is -16. 13 plus -16 is -3. Negative and negative makes a +6. So that is correct. So I'm going to have to suck it up and say, fine, that means that my answer is a -3, then an 8x, and then an x squared. Now when I write my remainder, I'm going to write plus 20 over and then x plus 2. So whatever I'm dividing by goes as my denominator. Okay, so if I divide and I get a remainder of 0, then this is a factor. So I'm just going to do synthetic division. -3. 3 is my coefficient of x cubed. 8 is my coefficient of x squared. -7 is my coefficient of x, and -14. So bring this guy down. -3 times +3 is -9. Add these together and I get -1. -3 times -1 is +3. I add these together and I get -4. -3 times -4 is +12. I add those together and I get -2. That means I have a remainder, which means that this is not a factor. You might want to double check me. So let's see. 3, bring that 3 down. This is -9. That's correct. 8 minus 9 is -1. That's correct. -3 times -1 is +3. That's correct. -7 plus 3 is -4. That's correct. And that's a +12. All right, so this one I can't use synthetic division on. So I am going to have to actually do long division. So 2x plus 5 divided by 2x cubed plus 5x squared minus 32x minus 80. So the first one there, I'm going to have to put an x squared. So x squared times 2x is 2x cubed. X squared times 5 is 10x, not 10, just kidding, is 5x squared. So all I've done is add an x squared to everything. So now I am going to cancel out 2x cubed minus 2x cubed. Remember, these are all minus. Cancel, cancel. So now I'm going to bring my next guys down. -32x minus 80. Okay, so -32. So what times 2 is going to give me -32? That's going to be a -16. So that's going to give me -32x, and then what is 16 times 5? So that is 30, 80. Hey, how about that? So that's negative 80. Look at that. Everything cancels out. So that means that it is a factor. And the product of the two factors is going to be the 2x plus 5. And then what I have right up here, which is x squared minus 16. And that's it. Okay, if you use zeros to sketch the graph of a polynomial function, how can you verify that your graph is correct? Okay, so let's see, what are our options? Use a graphing calculator to check the sketch. Sounds like a great plan. Calculate where the function changes from increasing to decreasing. Calculate the function where the changes from positive to negative at the turning points. Use the zeros to check that the x-intercepts are correct. Well, if I'm using the zeros to sketch, doesn't make sense to use these. I'm going to go with A because, heck yeah, that's how I would verify. Use my graphing calculator and check the sketch. All right, so this is a fun one. You know how to do this. You graph the left-hand side, y equals. You graph the right-hand side, y equals. That's what I've done right down here. This is left-hand side. This is right-hand side. This is old news. So I graph it, and I see this graph right here. And I go, and I put in my calculator. I put in my answers over here. Put -1 and 1, and it says I'm wrong. And I'm like, what the heck? What do you mean I'm wrong? This is right. You all are wrong. So I just went ahead and like took one for the team, and I checked the answer by just getting it wrong. And then it told me that my answer was actually wrong because there was another better answer. And then I looked at the graph and I zoomed it out, and I was like, well, heck, look, there's actually a third point all the way freaking up here, y'all. Look at that. It's way at the top. I would never have found that if I hadn't thought about it. So please double check on these. Zoom it out. See if it looks like it's going to intersect. I mean, when I blew this up here, I was like, well, I guess it does look like they're getting closer and closer and closer. I would never have thought that, y'all. So the moral of the story is that if you use the graphing calculator to do this, that you should make sure that you are zooming out far enough to find all the answers. So yeah, there you go. Okay, so this one was another fun exercise, and Ms. Zender just rushed through the answers. I looked at this and I said, oh, this is easy. The answers are gonna be 0 for this guy. So I needed to cross at x equals 0. Then opposite of this, so x equals 9, and opposite of this, x equals -9. Okay. So I went over here and I like zoomed out on everything, and I was like, oh, this one for sure crosses at 9, -9 and 0. This one over here was over at 21 or -21 or whatever, so it was like whatever. And then this one was like maybe, but oh, this guy didn't work. So I was like, oh, it's B. Didn't even think to check for D. Now, what's the difference between B and D? Well, B goes like this, and D goes like this. So this is a negative x cubed, and this is a positive x cubed. So what do we have in our function? We have a positive x cubed. So this answer is D. Now, you could avoid all of this if you just use Desmos. And you graph this thing on Desmos, and then you match up the graph. So this one is actually D. All right, so this one, all I did was I graphed it, and then it also asked to describe the behavior at each 0. So the first one at 0, 0, this is an x-intercept, and this is a bounce. Okay, so it's easier if I show you the answer choices. So the answers are it crosses. So this right here is an example of crossing. This is touching without crossing. If you ended up with one that went like this, that would be this guy. So it would cross here, and then it never touches the x-axis without crossing it. So our answer is letter C. It crossed at 0, and then it touched it and without crossing it at number 9. All right, last one. Same thing I did before. Make sure you do this one. You don't have to zoom out because the y equals negative 12 is pretty obvious of where it's going to cross. And so I graphed the y equals this side, y equals this side. You can see that here. Left-hand side, right-hand side, and then I crossed at negative 2. 1 and 6. When I put it in incorrectly because I said negative 1 here. That's wrong. So make sure that you do just use those x values, separate them by commas. In fact, I think this doesn't actually even have the parentheses. I don't remember how it looks in the answer key for when you're putting it in Savas. So that's everything I got, y'all. Happy studying and good luck. Don't forget there is a take 2. If you screw up the first one, you can take the second one, and I'll take the better of the 2 scores. See y'all soon. Bye.